So, FishBase has a number of routines to infer traits because lots of people use FishBase for traits analysis, the features that the fish have. And some of these features or these traits are entered specifically, some of them are calculated. And the ones that are calculated have rules behind them. For example, we infer length-weight relationships from existing length-weight relationship, and then there is a Bayesian routine that estimates length-weight relationship for fish for which we don't have a length-weight relationship. And the more length-weight relationship empirical we enter, the better the routine is. But this routine and other routine need extreme values because they need to be tested. They need to work also with extreme values. Extreme values is a big fish, a small fish, a very thin fish, a very fat fish, and we should enter as much as possible extreme values, extreme fish, in order for the routine to work best. Now, extreme can also be a weird shape, and I have worked with, in this spirit, with this fish here. We have done length-weight relationships and growth because I got from the public aquarium, from this lady particularly, working in Woods Hole in the aquarium, wonderful data that allowed this fish to be put in FishBase with features, traits, length-weight relationship, growth, and so on. So this is the weirdest we could get, but handfish also is weird. They have this weird shape. They walk on their hands, and they are threatened. There is these fish are under tremendous pressure. There is only a few hundred left in Tasmania, and you cannot sample them and get the otoliths and do horrible things to them because they are protected, and people have them in aquarium, and then that means everything that is published about them should be used and squeezed like a lemon to last drop, because otherwise, because we cannot sample them in the field. And so there is a paper appeared in Journal of Fish Biology that promised the population parameters of this handfish that is highly critically endangered, and so I look at the paper, and I was going to forward it to FishBase so they could get the population parameter, but there was no population parameter. What there was a table with the result of tagging. They have tagged the fish, and they were a certain size, and they grew, and they also moved from one place to the other, and they were some days off, and basically they didn't notice that one could estimate growth from this. And so I took the data here and rewrote them in this format. That's the mean length at tagging, the class. That's the number of fish in that class, the day that at large, the length increment when at large, the annualized length increment in over a year, and that's the mean length while at large. That was done for each length class. This was done in half an hour. And then the growth parameters were estimated using a very simple method where you plot the growth increment against the mean length. Then you get the von Bertalanffy parameter as the intercept here, and you get the slope, the K parameter, as the slope. And that was it. And the method is available since 1959, but they didn't know. They had all data to do this. So I wrote them, and I said, do you also have the weight, the length-weight relationship? Because they didn't, but they were friendly enough to do a length-weight relationship, or to send me the length and the weight of the fish that they had in captivity. Here they are. And we do the length-weight relationship. And all of this was then written in a little paper that is now in press, that it's not in a peer review journal, it's in a report series. It will appear in a few weeks, and it will be sent to in September for encoding. That's the first fish for which we have length-weight relationship and growth of that family. So when we make inferences about a length-weight relationship and growth for that for fish of this kind, we will have something. And I recommend this approach. I do frequently papers of that kind, little papers squeezing a lemon for a few more drops of juice, and send them then to Los Baños for encoding, so that the extreme, the very small fish, the very big fish, the weird fish there, the weird fish there, are covered. And also I do this also for invertebrates, so that the routine that we have and the traits that we present are covered, or the whole range of trait that can appear. For example, if we show growth parameters, if we have the biggest one and the smallest one, we have the frame that we need to have, and that makes, for the programmers, is actually useful. And Rainer and Deng did a similar study a few years ago on the coelacanth, Latimer chalumnae, because this is a weird fish. It's not even a fish. And I would recommend that we can do that to amuse ourselves. That was written probably in a day, and an email to, and so if you have a weird fish, extreme in some sort of way, with a trunk or with horns or something, you do the basic traits and send it to FishBase, because it then will prevent extrapolation. You will then always interpolate, which is always better. So that's a short and sweet presentation. You have a question?